Okay, welcome back. This is part 2. Now, we ended up here in the part 1 of just using Tracker to do X and Y, and that's really what we want them to do in Year 11 in the preliminary course, is to use X and Y and come up with a way of doing finding the velocities from that. But, not unfortunately, but fortunately, you can also cheat a bit here. This thing over here called data, if you click that down there, you get a whole lot of other data possibilities that the computer will generate in this column section over here. This, if you tick on the X and Y, now this is, we're going to do in a few more moments a track in X and Y motion, but I just want to do this one here as the X motion. So this here is the velocity in the X direction, just simply the X thing. And by the way, you can see down here, you can also do the acceleration in the X direction as well, and you get an average acceleration there. That's what we're actually trying to find. So you might just click that off there for a few moments. And they can click these on and off, and they can check see how accurate their data is. So just closing that there, I'm going to retract this. So quick way of getting it. By the way, remember this here is a part of my video capturing device, so it's nothing to do with the Tracker program. So I'm going to now create a new point mass. I'll delete the old point mass, and I'll create a new one. And I'm going to make it a nice colour, yellow over here, and say OK to that. As soon as you create the point mass, you'll see shift click to mark mass G. Come up. Now I'm going to get the, someone's knocked the camera there, and there it is, it's ready to go. Okay, so once again, clicking, hopefully if I shift click correctly, never been good at this one. Okay, and okay, so shifting and clicking. Trying my best to get it right, the nose, to make my average as possible. And just shifting and clicking, holding down that shift key, don't try and, okay, we might just leave that one, yeah, I might just go there, one more, that's it. Okay, so there's my data, I'll get rid of that, and once again, we've got the motion up here. Parabolic, trying to show you that it's actually reasonably accelerated. Obviously, if we want greater acceleration, we could do the put a bit more weight on it. And now I click on my XY velocity, and here is the VX velocity. So let's take this data now. You can highlight it, and you can copy it, and you just simply need to paste it into an Excel spreadsheet. So this is the old one, so we'll get rid of that one. Let's go sideways. I'll just go new sheet, probably easier. There. Okay, now that one there was my X. This was my Y, so I'm going to get rid of that one. And this one here was my velocity. Notice that there's no velocity for the first one or the last one, because it does require two velocities, an beginning and an end, just to calculate it. So I'm just going to move it in sideways here. Oh, actually, I might just copy this stuff here and put it over here. Okay, so this is my time against velocity. So I'm going to now plot this little section just here. So inserting, and you make sure you always use a scattergram, obviously, as you know, and you get a nice one like that. There is the plot of that. It's a little bit rockety, but it's added a trend line, and we know this has got to be a linear trend. And I'm going to go down here and say display the equation on the chart, and there it is. There is the equation of this. It's y equals mx minus that. So I'll just get the pen up. So we've got, obviously this is velocity versus time. So this is v equals u plus at. So therefore the and t is on the x-axis. So this must be a. So the average acceleration is 0.733 with this data, using that as a mean trend line. Okay, so that would be 0.733 meters per second squared. So just you can get quite an accurate set of data just simply from just using this tracker program with an Excel spreadsheet. Okay, so now we've done that, let's try, and in year 12 we have to, well, I use this as a projectile motion track. So let's get a projectile motion thing. I'm just going to pause the video now while I load in a new video, and the new video will be a projectile. Okay, now we have another projectile motion track. Okay, and here I'll just play the video so we can see it. So you can see that the students have set up a projectile apparatus at a certain angle, letting it play. They're videotaping their own trial number so they don't have to record it anywhere. And they're just letting a projectile ball bearing go. And it's about now, I'd say. Yep, there is the projectile moving. And notice very clearly in the centre of this is a standard measure, and obviously they just used a ruler as it's, and against a background. The background there is so they can more clearly see the ball bearing as it moves. Okay, so I'm going to very, very quickly track this to show how quickly it is done. The first thing we do is we set up the axes. I'm going to set up the axes at the moment that the ball bearing comes out, so I'm just going to move the video back until we see the ball bearing. There's the ball bearing going, and there is, let's say, the first time I see the ball bearing down, and I'm going to move, I'm going to track the tip of the ball bearing. So that's going to have my beginning of the motion. And next I'm going to check the length. So here it is. So there's that length there, and putting it on, I move that. It doesn't matter if it's tilted, make sure you get it right, and clicking in there, I just type in the number 1, press enter, and that is setting that length there in this video to being 1. That must be done for every video that you track. The next thing is to create a new point mass, and give it, in this case, definitely a good colour, because blue is not very good. And so okay, and once that happens, you get the shift click to mark mass H, or up to mass H, because I've deleted so many. And I'm going to advance the video until I firstly see the motion of the ball. There it is. There. Look at that. Rightio. Holding down the shift key, I'm going to track the beginning of the blur. Now, it's such a fast motion that we'll see the ball bearing not as a dot, but as a line or a cylinder. So holding down the shift key, I'm going to track it. It advances itself, clicking each time. Please notice that, know that if you're using another computer with the right codecs, you will actually see little dots or little triangles marking each of these tracks. Okay, if what I just did was I accidentally clicked the wrong thing, I held down the shift key and I'll let it go, or something like that, and my my shift click has gone away and it won't advance anymore. So the best way of doing this, if this happens, is simply delete the mass and start again. So new point mass, it doesn't take too much time to do this. You don't have to do anything else apart from change the colour. And then just get it into position again one more time. So, sorry about that. There we are. Okay, once again, ready to shift click. I'm just going to put down all the pens I'm holding. Okay, 1, And again, it's easier if you have a mouse rather than a trackpad. Now, when you're doing this motion here, you just have to track as much as you possibly can. It doesn't really matter that you go underneath the motion. The whole point of this was to work out the velocity that it came out of the muzzle. Okay, so we'll just go to there. Okay, that'll do. You don't have to track the whole motion, just enough to get the accelerations and velocities. Okay, having a look over here, I'll just make that a bit bigger. We can now see the same data that we had before. We have the time. Remember, the first time here is the time that came out according to the video. It's 4.8 seconds after the video shutter was activated. And this is my X coordinate and my Y coordinate. So I can have the plots, and we can plot 1 against 2. So this one up here is the horizontal motion. Notice it's a straight line. If I was to just put it down there, that means I've got a nice, the gradient of that line there is my horizontal motion. And this is the expected curvature of the Y motion. So once again, you can simply, if you want to do a greater analysis with the data, you simply can highlight all this data, and you can then paste it into an Excel sheet. Also, you can turn on X velocities and Y velocities. So here we can see that, if we look down here, that we can read off, we can even average those if we wanted to, that it's around about 3.2 meters per second as the Y motion, and here is the variable motion there in the vertical. So I hope this helps. You can use this program to use it for analysing data or motion, and you can use it in any context. All you need is to track one point of the motion. Just a few pointers and tips while I'm here about trackering. If you are trackering a trolley, I've discovered that using the Dynamics trolley, the white wheels of a trolley are great to track because they often have an axle in the centre, and it's always easy to spot. If you are using a cyclist on a bicycle, then a join on the actual frame of the bike is probably the best one, something that can be always seen. Don't use the head of the cyclists themselves because that can be bobbing up and down, or you could use the cross brace or the centre once again of the wheels. In cars and traffic going up, then obviously the problem with this one, of course, is that you can't stand really beside the car. It does need to, it's at an angle to your track, so you will get a distortion. But it's also good, once again, the wheel is the easiest on the front bonnet. Okay. Okay, I hope this helps, and any questions, you can always ask me or email me.